Rational means you have a fraction, so we're looking at equations involving fractions today. So we're just going to jump right in. If I ask you to solve this equation, where would you begin?
Great question.
That is a great question.
I don't even know.
Okay, let's talk about that. So we know that if you have a fraction, what can never happen in the denominator? The denominator cannot be what? Zero. The denominator cannot be zero. So if I look at this, can you tell me right now what x cannot equal? X cannot be 1 at the very end, because if my x is 1, the denominator turns into 0, and that would be, what is that on the graph if the denominator is 0? Only if it cancels. Vertical asymptote. So it's a vertical asymptote on my graph. We can't have that. So when we are solving this, if we get 1 for our answer, what do you think we're going to say? No solution. It can't happen. All right. Knowing that, what about this problem makes it tricky? Probably the fact that it's a fraction. Okay, we don't like that. So, if I wanted to get rid of it, what's the opposite of dividing? Multiply. So what we can do is multiply to get rid of all of our fractions. Now there's essentially 3 terms here. So whatever you do to one, you have to do to all 3. So if I want to cancel my first denominator, it's a 2. So I have to take all 3 of these times a 2. That cancels this, but did I get rid of all my fractions? No. This denominator has an x minus 1. So if I want to get rid of an x minus 1, we could take all 3 terms times x minus 1. If we do that, now all my fractions are gone. So what I'm left with is 2x minus 3 times x minus 1. A 2x times 2. And over here, we have a 2x times an x minus 1. Does everybody understand how I got to this step? Is this something we could solve? Yeah. What would we have to do? Distribute. Start multiplying this out. So here we FOIL. So we get 2x squared minus 2x and minus 3x would be minus 5x plus 3. That's that one. This would be the 4x. Over here we get 2x squared minus 2x. Combine like terms. We always try to set quadratics equal to 0. If I subtract over my 2x squared, what happens? Let's cancel. Okay, so then if I just add over my x, divide, and x is negative 3 plus. First of all, is that an okay answer? Can x equal negative 3? Yeah. The only thing we could was +1. So we always need to go back and double check. Is there a way you could check to see if this answer is correct?
Plug it in.
Yeah, all you have to do is go back and plug it back into the original equation. So our goal in these problems is going to be getting rid of our fraction, but at the end we do need to double check our answer. Okay, you can plug it back in or at least verify that it does not make the denominator 0. Let's try another one. So can you tell me right now, what can x not be? Mhm. Okay, so we're just going to kind of keep that in mind until the very end. What's my next step? Yeah, we need to get rid of the denominator, and to do that, we multiply. So to get rid of the first one, we have to multiply everything by x minus 5. Okay, so we really have 3 pieces here. I'm going to rewrite it. I need more space. So multiply this. X minus 5. Whatever you do to one, you have to do to every single term. So those cancel, and those cancel. Is there anything else we have to multiply by?
No.
No, fractions are gone. So we have x plus 5 times the x minus 5 equals 5. So we get 6x equals 30. So x is 5. What does that tell me? No solution, because we know 5 makes the denominator 0. So that answer is not possible. Any questions there? Another one. Can you look at this and tell me what x cannot be? Mm-hmm. That's the only thing that makes the bottom of this fraction 0. Alright, so for the first fraction, if I want to get rid of this, we have to multiply by the whole denominator. So we're going to take it times 3x squared. That would cancel all of this. Because it's all one term, it also cancels the x out of that denominator. So what's the only other thing we need to multiply by? 2. We don't need another x. Okay, so then those are gone. And we have a 6 over here, but 2 times 3 is 6, so that cancels. So what I'm left with is 7 times 2, 9 times 3x, and negative 13 times x squared. Now what? the 13 over.
Mm-hmm.
Alright, so we could do slip and slide here. That's true. What multiplies to 182 and adds to 27? Mm-hmm. Okay, multiply by 13. So if we set those equal to 0, we get -1, -14 over 13. What do we need to verify right now? Very end, we always have to double check that what is true. That the denominator is not 0. So we said at the very beginning of this problem that x couldn't be 0. So both of these answers are okay. So we've seen some problems where we had 2 answers, some where we had 1, some where we had a no solution. Any combination of those is all right. Let's do another one together before I have you guys try one on your own. This one, we need another step that we haven't had before. Do you notice anything different about our denominator? More specifically, the x squared minus 2x. Yeah, let's go ahead. You don't want to multiply by more than you have to. Because if you multiply by extra stuff, it can take your problem and make it significantly harder to solve. So always make sure your denominators are factored. X minus 2 we can't do anything to, x we can't do anything, but x squared minus 2x, you could take out an x and then you're left with x minus 2. So right now, x cannot equal, what makes x minus 2 equal 0? And then this one's just plain x, so that is 0. Okay, so there's 2 things x can't be on this problem. So now if I want to get rid of my fractions, we have to multiply by the x minus 2. So those cancel. And because I factored, I can cancel out this x minus 2 over here. What else is still on the bottom? X. So everything gets an x as well. You do it to one piece, you do it to all. So those x's cancel. So we have 3x plus 2 times x. 1 times x minus 2, and then a negative 2. We multiply it out. Okay, add my like terms. 2x plus x is 3x. We want to set it to 0. If I add my 2 over, what happens? Now what? You gotta 3x. That leaves us with x plus 1. So if we set those equal to 0, we get x equals 0 and negative 1. Are those okay? No. We said at the beginning x couldn't be 2 or 0, so we have to throw out the 0, so our only answer is negative 1. I'm going to put one up here that I want you guys to try. So first one, we always factor first, so we don't want to make our problem too hard. So we can take out an x, that leaves us with x minus 7. X squared minus 49 is x plus 7x minus 7. So to cancel the first denominator, you have to multiply by everything that's on it, x and x minus 7. Come on.
Can I have those handouts?
Yes. Also, I just opened up your email last night, so that's why I responded.
I did take it off.
Alright. So, over here the x minus 7 drops, but what do we still need?
X plus 7.
Okay, so everything gets x plus 7. So then those drop and all of our fractions are gone. So we have 4 times the x plus 7 minus 1 times an x. And 0 times anything is just 0. I failed to write down here. What can x not be in this problem?
0 plus minus 7.
Everybody knows where those are coming from. Those are the vertical asymptotes, so that isn't part of the domain. So negative 28/3 is acceptable. So that is our final answer. Yes, Kate?
Does it make any difference if we just threw the x on the end instead of adding the x minus 7?
Say that again.
Does it make any difference instead of like taking the 7 and putting it in, adding it
no,
at the end?
not at all. Is that okay? Let's try one more for today.
Ew.
Isn't that beautiful?
No.
I think
Beauty
that-
is in the eye of the beholder, and I don't think I want to behold this.
Yeah, I think this
Well, that's rude.
is my cue to drop out.
Oh. Cut it out. Whiners.
You could be doing my stuff.
You have fun, Candy.
What do we do
Honestly, I'm
first?
looking at trying myself to do factor.
Factor everything. Okay, x squared minus 5x plus 6. What does that factor into? X squared minus 4. What's that factor into? Alright, over here, what do we have to do on that one? Yeah, well,
Or no, you can take 2 out.
yeah, if we take out the 2, and then that would factor. What multiplies to negative 6 and adds to negative 1?
6 and 2. Okay, so we factored everything. So we have a list of what x can't be. We have an x minus 2, so x can't be a 2. We have an x minus 3, so x can't be a 3. We have an x plus 2, so it can't be negative 2. X minus 2, we've already got that. 2 never equals 0, so we don't have to worry about that. We have all of them. So now to cancel the denominators. For the first fraction, we have to multiply by x minus 2, x minus 3. Those drop. So the first fraction's good. What do we need for the second fraction?
X plus 2.
Cancel those. Is there anything we still need? A 2 for that final fraction. Now all the denominators are gone. So we have, let's see, 2x times 2 would be a 4x times the x plus 2. 1 times 2 would be 2 times the x minus 3. And over here we have x plus 3 times x minus 2. Now we start multiplying out. So quadratic set them equal to 0. If I subtract over my x squared, subtract over my x. When I add my 6, lucky for us, that cancels. And then we have a GCF. So we get x equals 0 and negative. Are both of those acceptable? Yep. And if you weren't sure, or if it's a test and you really want to make sure you were on the right track, what could you do at this point? Plug them back into the original and check yourself that way. All right. Any questions for me? You okay, Grayson? Just getting all choked up. That was such a beautiful problem. I know.
It was done so beautifully.